arc length. So in this one, we're going to be given another diagram of a circle. And we're being asked to literally find arc length. That's why it's titled that way. So they're going to ask us to find either the minor arc or the major arc. And we've done this on a couple other videos. So minor arc is when we're talking about an angle, and here's the angle that's created here, this 130-degree angle that they gave us in the description here. So let's go ahead and read the description real quick. So the circle below has center C. So here's our center. And the radius is 4. They don't have this marked anywhere here. So both of these are radii. And the reason is they're going from the center to the side, from the center to the side. So that's one of the definitions we've learned about circles. Given that angle DCE is 130 degrees, which they did mark here, so DCE, find the major arc. I'm going to change my color here. Change it to kind of this weird lime green, which is DFE. I'm trying to just go around here. So this is the arc they're asking us to find on this one. So a major arc and a minor arc. The minor arc is in between. It's the arc created by the angle that we're talking about. So DE in here, let's put this in, I'll put it kind of in a light blue. So this is the minor arc that's created by this angle DCE. And then the major arc is kind of the back side of it, if we went backwards. So think of it like the small arc that's created by the angle, and then the rest of the circle, which is the large arc. So they're asking us to find the large arc, the actual length of it. So we need to go back to when we were doing circumference of a circle, because that's how we find the measurement on a circle on the outside. We need to know circumference. So circumference equals 2 pi r, or diameter times pi. Because remember, every diameter has 2 radii in it. That is, again, another one of those properties that we've learned about circles in the last couple of weeks here. So we have these two to find the circumference of the entire circle. Well, we don't want the circumference of the entire circle. We just want the length of the one arc here, this green part. So what we need to do is find the fraction of the circle that is. And I know I'm saying fraction, but it's not as terrible as it sounds. So you have arc length equals, and you do the arc itself. So what's the degree of the arc? So I'm going to put arc degree over 360. So we divide the arc degree by 360, and then we multiply that by 2 pi r, which is our circumference, or diameter pi if that's what we have. So this is our equation. This is what we're going to use to do this problem right here. So arc length equals, we do the arc degree divided by 360, and then we multiply by 2 pi r. So if we have this one, so we have this 130 degrees. That's all we have right now. But again, another property we've learned in the last week about circles is if it's a central angle, meaning it's coming from the center and going to the sides, if I have that center angle or central angle, then I have the arc. So if this is 130 degrees, the arc, the blue arc here is 130 degrees. Well, why do I care about the blue arc? Well, because I know the whole circle is 360. If I have the blue piece, I can just subtract from 360 the blue piece, and that'll tell me what the green arc is. So I get 230. So now I know what my arc degree is. It's 230 degrees. So I can go 230 divided by 360 times 2 pi times r. And remember, they told us up here, and I marked it on the diagram for us, r is 4. They told us the radius is 4 feet. So, and they don't give us a calculator on this one. Let's see. Give an exact answer in terms of pi. Okay, so that's what I was looking for. The second sentence here, which I hadn't read out loud, that's bad. Make sure you read all of the directions. That's one of those big ones. So give exact answers in terms of pi, which means they don't want us to do anything with pi. Pi is actually going to be in our answer. So what we're going to do is we're going to reduce this one. this 23 over 36. If two numbers are being divided, and that's what this fraction bar means, they're being divided, and I have them ending in 0, I can just cross off the zeros. That cancels. They're both being divided by 10. It's just kind of an easy way to do it. So now I have 23 over 36 times 2 times pi times 4. So now I can start cross-canceling, and I'm going to put 1s under this 2 and this 4 so that you remember. The 2 is on top, the 4 is on top. Every single number you have ever seen in your whole life has a 1 under it. We just don't write it that way because it would definitely start to look a little confusing. But in this case, it makes it helpful because now I can start canceling from top to bottom because that's how you cross-cancel. One has to be on top, one has to be on the bottom. So 23 doesn't really cancel with anything, but 36 and 2, those are both even. So I can divide 2 by 2 and I get 1. I can divide 36 by 2 and I get 18. So now if I take the rest of my pieces here, and you can use a calculator outside of here just to confirm everything. That's perfectly fine because for whatever reason they don't have the calculator enabled. So now I'm going to continue cross-canceling. I'm going to jump all the way over here 4. Everything is being multiplied here. So that means I can cross-cancel anything in here that matches up. So 18 and 4, those are also even. I can divide by 2 again. 4 divided by 2 is 2. 18 divided by 2 is 9. So I have a lot of canceling here. Let me clean this up. So I have 23. Now I'm left with just 9 on the bottom. Times, this is 1 over 1. I don't even need this anymore. I can just go pi because anything times 1 would be itself, so that's not needed. And then this one is times 2 over 1. So I've done all the canceling that I can possibly cancel. So now what I'm going to do is, with fractions, I'm going to multiply straight across the top. And I'm going to multiply the numbers. So 23 times 2, I get 46. 9 times 1, I get 9. And then I'm going to have a pi stuck on the end there. So let's scroll down. This should be 46 over 9 pi. And then make sure that you select the unit that they're giving you. They told us that the radius was feet and circumference is just a length. It's like if we could take the circle and unwind it, I could probably use a cord here. So we have a circle out of my cord here. And I know it's kind of a wonky looking circle, but I have a circle. Circumference just literally means if I could take it and cut it, and I could unwrap it like this. So it's the circle is from my fingertips to fingertips. So we just want to know how long is this cord that created the circle a moment ago. So that's all circumference means, is how long, if I could unwrap it, how long is it? And when we're doing arc length, what we're doing is we're saying instead of the whole thing, I don't want the whole thing, I only want this piece of it. So the piece that I just let go of on that side, I don't care about that piece. I only want this one. So we're just measuring around a circle, but we're only measuring part of the circle in this case. Okay, so let's go ahead. I'm going to clear this out and we're going to go ahead and start this. We do need to keep a couple of these things in mind. So let's go ahead and mark what they haven't given us. So they tell us we have a radius of 7. And remember, radius means it goes from the center. And they tell us the center is K. Goes from the center to the side. So this is 7 centimeters. And this also goes from center to side. This is another radii. So we have 2 radii. And then they also give us that LKM, so angle LKM, is 70 degrees. They do mark that in here, right here. So they tell us that part. And they want us to find the minor arc. So I'm going to go minor arc. They want us to find this length here. And I didn't change that color very well. I meant to make that a little brighter. So they want us to find this pink arc out here. So now we need to know, well, what's the measurement of the arc? We have to go back to what we know about central angles. That's an angle created from the center of the circle. If I know the measurement of that angle, I know the arc because the central angle and the arc are exactly the same. So it does seem like that's pretty common. They're going to continue to use that idea. So now I'm going to go through and I know arc length, forgot my T, equals the arc degree divided by 360. It's always divided by 360 because all the way around the circle is 360. I want to know what fraction of 360 are they using. That's why we divide by 360. We're saying we're only using a piece of the circle. I want to know what the piece is. And then we multiply by circumference, which is 2 times pi times r, which they told us is 7. All right, so let's go ahead and start reducing this one. Again, they both have zeros, so I can just cross the zeros off. So I end up with 7 over 360. Oops, sorry. Not 360, 36. Silly me. Times 2 times pi times 7. So they're all times again. Remember, they all have a 1 under them. So the 1 I'm putting there just to help you remember, everything is a fraction. Even numbers that we don't normally view as a fraction have a 1 under them. So you can always convert them to a fraction so that you have a top and a bottom, because that makes it a little easier, at least in my mind, it makes it a little easier to match things up and make sure you're cross-canceling correctly. So let's see, I'm going to go to blue here, and I'm going to cross-cancel. So I want to go from bottom of the fraction to the top. And it can be in the same fraction, like we did here, 70 and 360. That was the same fraction. And basically what I'm doing here is I'm dividing by 10 when I cross off those zeros. And that's cross-canceling, or that's just regular simplification. Cross-canceling means we're going to cross from one fraction to the other, but we still need to go from top to bottom. So it can't be both denominators and both numerators. It has to be one numerator, one denominator. I said that backwards. One numerator, one denominator. Sorry, silly me. My references were funny. All right, so let's go ahead and look at 36 and 2. So I know they're both even again. So they can divide by 2, and I get 1. And I'm going to divide by 2 here, and I get 18. All right, so if I jump over here to this one, I have 7 and 18. Well, 7 and 18 don't really talk to each other at all. There's nothing I can divide. 7 is prime, so it doesn't divide into smaller numbers. And 18 doesn't divide by 7. So I'm going to rewrite this one because I didn't really give myself enough room here. Let's see, move this up. So I have 7 over 18, because I'm just rewriting this, times, now I have 1 over 1. I don't need that one. Once you get 1 divided by 1, it is 1. Anything times 1 is itself. So this basically cancels itself out. We don't need it there. And then over 1 like this. So this is what I'm left with. So this is still our equal sign. I forgot to carry that over. So now we're going to multiply across the top and across the bottom. 7 times 7, we get 49. 18 times 1, I get 18. And then I'm just going to put pi on the end. Don't forget to grab the unit. If you try to click check, if you type just this in and you click check, it's going to warn you and say, you forgot to select your unit for your answer. If you try to click check again without selecting the unit, it's going to mark you wrong. So make sure you select the unit. They told us it was 7 centimeters. So it's 49/18 times pi centimeters. All right, so we go 49 divided by 18, and you can click on the fraction bar. I just use the backslash. It puts the fraction in there for me. Just make sure, if you click pi right now, it's going to go on the bottom of the fraction. We need to hit the over arrow, or actually click over here so that it goes next to the fraction. And then click centimeters. All right. Yay. Clear. Next. Okay, let's see. Kind of a like dark purpley color. That was kind of weird, but I liked it. Let's see. We have the center of the circle again. So we have the center of the circle and the radius. So they're telling us a radius of 3. Remember, that means you're going from center to side. So here's a radius, and then center to side, here's another radii. All right. And then they also give us that angle AOB is 30, and they mark that for us right there. They tell us 30 degrees. They want us to find, I'm going to do this in kind of a bright red here. They want us to find this minor arc here, which is AB. So let's go back to thinking about central angles. If I know what the central angle is, and I know it's a central angle because it goes from the center to the side, then I know what the arc is. It's 30 degrees because the angle is 30 degrees. So if it's an inscribed angle, I don't believe they're going to do that to us on this one. But if it is an inscribed angle, it's half the arc. But if it's a central angle, it's the exact same. The arc and the angle are the same. So now we have arc length equals the arc degree, which is 30, divided by 360. And then we go times 2 times pi times radii, which is 3. They told us that. So now I'm going to reduce. Remember, this means I'm dividing by 10. So I have 3 over 36 times 2 times pi times 3. I'm going to put my 1's under here. All right, let's start reducing this one. So we've already done this one a couple times. I know I can divide by 2 for both of these. 18 and 3, those actually can reduce from top to bottom here in the same fraction. So I can divide by 3, and I get 1. I can divide by 3 down here, and I get 6. And now I can go from top to bottom. I'm going to go out to this 3. So 3 is on the top of the fraction, 6 is on the bottom. I can divide by 3 again, and I get 1. I can divide this one by 3 again, and I get 2. So I know that's a whole lot of crossing off, so let's rewrite that. So on the top here, I'm left with just 1, because that's the only thing left on the top. On the bottom, I'm left with 2. 1 over 1, well, that cancels out once we get 1 over 1. Times pi, well, this is also 1 over 1, because that's the only thing left over. So I'm already at my answer. I don't have to do any more reducing or multiplication once I get here, because everything else canceled out. So we have 1/2 times pi. Make sure it's inches, because that is our unit that we need to type in here. So we have 1/2. Make sure you leave the denominator of the fraction before you click pi. We don't want the pi in the denominator. And then inches. Check. All right, we did that one. Let's do the next one here. Next. Okay, so we have center P. And the radius is 9. So they're telling us we have a radius of 9. So we go from center to side. Here's 9 meters. Center to side. Here's another 9 meters. And then they tell us that QPR is 160, which they have marked here. And they want the major arc. So remember, major arc, all that means is they talked about QPR. So here's the minor arc right here. So this is our minor arc. The major arc, which let's see, we'll do this in kind of a hot pink here. The major arc is the kind of the back side of the angle that they were talking about. So it's going backwards. So it's this major or larger arc usually for the major arc. Okay. So what we need to know is, what is the measurement? What is the degree of the major arc? So central angle. If this large one is 160 and this is our angle, then this central angle or central arc, sorry, the arc from a central angle, mixing up my words there, is the same. Why do I care about that? Well, the whole thing is 360 all the way around the circle. If I know I'm already using 160 for this red portion that I don't want, I can just subtract it. So the pink portion here, change it up here. So the pink portion here is 200 degrees. So now I can go my length equals 200, which is my arc degree, divided by 360 degrees, times 2 times pi times radii, or radius, which is 9. All right, so now, again, immediately if they end in zeros, I can cross those off. The same thing as dividing by 10. So now I have 20 over 36 times 2 times pi times 9. All right, so let's go ahead and keep reducing. So this one actually can keep reducing past just crossing off the zeros again, because 20 and 36, both of those, let's see, they can divide by 4. So if I divide by 4, I get 5. If I divide by 4 on the bottom, I get 9. All right, so now let's put our 1's under here so we can look. So we have 2 and 9. Well, 2 and 9, those don't reduce at all. But I have 9 on the top on the end and 9 on the bottom over here. 9 divided by 9 is 1. And 9 divided by 9 is 1. So let's rewrite this so that we can see what exactly is left over here. So I have 5 on the top here. 1 on the bottom. I have 2 on the top here. And 1 on the bottom. And then pi, and then I have 1 and 1, so that cancels itself out. So now we're just going to multiply across the top and across the bottom. I have 5 times 2 is 10. 1 times 1 is 1. Times pi. Do I really need to write it as 10 over 1 times pi? Or can I just change this so it's 10 pi? Can I drop the 1? Just like 2 didn't have a 1 in the first place and neither did 9? Yes, that's exactly what I want to do. So when I type this in, oh, and make sure you put the unit on there. It was meters for the radii, so it's going to be meters for the length. So I can just go 10 pi meters. All right, we finished another one. Yay!